And some fever a few days ago, and my voice hasn't quite returned yet. So
Acha.
apologies for the voice. Yeah.
Oh, that's
All right.
fine. Okay, so let me start the recording. The recording is on. Okay, I hope all the participants are there. I can see the 48 list. Okay, that's great. Um, yeah, so let me introduce second speaker of the day. Today we have with us Mr. Rahul Ghosh, who is the skilled WebXR engineer with expertise in extended reality, XR, app development, and backend systems. With a Bachelor of Engineering in Computer Science from our host institute, that is Army Institute of Technology, Pune, Rahul has consistently demonstrated excellence in emerging technologies. He started his career as a research intern at Tata Sons Limited, Pune, focus on machine learning projects using PyTorch and TensorFlow. Then he worked as a backend engineer at Prodigal, where he worked in the backend systems. Yes.
Yes.
He worked on Python, AWS, Redis, Docker, and Linux systems. He is a popular freelancer where he's working on various extended reality apps and the XR works with GeoTessert and MetaRap. Currently, he is working as a WebXR engineer at Infinite Reality, Norwalk, California, where he's actually working on developing cutting-edge WebXR solutions for various immersive experiences. So today he's going to talk on the cosmic visualization, the AR VR as a tool for space domain. Over to you, Rahul. You can take the charge and
All right.
begin with the session. Yeah.
So what I'll do is I'll quickly share my screen. Is my screen visible?
Yeah, it's visible.
All right. So today we'll be mainly be speaking about augmented reality, virtual reality, what they are, and how exactly they can be utilized and applied in space missions and for space technology. So when we speak of space technology, we basically encompass everything that has to do with space, anything that has to do with technology inside space, obviously, including like rockets, astronauts, uh, vehicles, extraterrestrial vehicles, rockets, and their training and everything else. So the main thing is these are the contents of the presentation. First would be introduction to AR VR in space. Second is applications on space missions. Third is technological benefits. Fourth are the challenges and the limitations that are still present in implementing these technologies into space and how why we are not able to implement them at 100%. And the fifth is the future prospects of such technologies in helping humanity achieve a frontier beyond the stars. So, I hope my voice is clear and understandable.
Yeah, yeah, we can understand.
All right.
Good.
So number one would be let's start with introduction to AR and VR and its applications in space. So before we start about AR and VR in space, let's talk about what augmented reality and virtual reality themselves are. Let's start with augmented reality. Augmented reality basically allows us to overlay digital content on the real world, enhancing the physical environment through devices like smartphones or AR glasses. So basically, we have devices like our AR filters. We have technologies like our Snapchat filter, Facebook filter, Instagram filter. In fact, the very I can in fact show you an example of augmented reality right now by applying a background to my background to my screen. This is a type of augmented reality. Along with that, filters and all that, there are minor form of augmented reality used on 2D screens. At the same time, when we have 3D devices or 3D headsets or AR glasses, suppose, We can use them, and in fact, even VR headsets like these, we can use them and overlay information on the real world and enhance. A few examples of them could be me adding a furniture into a 3D space and being able to visualize that in real time in my own 3D space or in my own home, putting a 3D model of a furniture. That's an example of one. Yeah, and so on and so forth. Moving on. Second is virtual reality. I believe the audience would be very, very familiar with virtual reality, but I'll still explain it a little bit. Virtual reality, as you all know, immerses the user completely in a virtual environment. So this is the type of device you would use. Let me quickly show you. Yeah. As you can see, this is a Meta Quest 2 old generation VR headset. This is the VR headset. You have the lenses, the front body. There are four cameras in front, which you might be able to see, which is right here, camera one, camera two, and camera three, camera four, and so on. Some advanced versions of the VR headset also have LiDAR sensors attached to the front. If you see Quest 3, it has three depth sensors in front, which allow for better 3D calibration and 3D awareness of the device and the user in space. So when I mean space here, I mean 3D space, not cosmic space. So yeah, that's virtual reality. A few examples of virtual reality we can actually see. Not very clear. You need a virtual reality headset to be able to completely understand what virtual reality is. But a very recent example of where virtual reality could have been used is uh, mainly in maybe some people might have seen Prime Minister Modi wearing virtual reality headset to see the Vande Bharat Express visualization of the Vande Bharat Express back in 2024. That is one of the prime examples of the uh, prime time where virtual reality is been limelight. And obviously, we all know about Meta, and they are expanding efforts into virtual reality. Now, going back to the slides, the third is mixed reality. Mixed reality basically combines augmented reality and virtual reality. So, in mixed reality, what happens is you get a VR headset like this, you put it on your head, and the level of immersion you get in your physical space gets augmented with virtual objects in a much higher degree. For example, I have a bed in my real physical space. In augmented reality, maybe I can only put something on the bed. A small model can be displayed on the bed. But in mixed reality, using this VR headset, I would have mapped the entire bed into my virtual space, and now the bed itself can be used as a digital twin and can be interacted with digitally. So maybe I can touch the side of the bed in virtual reality, and that can cause some changes on the bed itself. It's kind of connected to Internet of Things, smart objects, and everything else. It's a more interconnected concept of mixed reality, which does not just involves overlaying digital information, but it blends digital and physical information together to create a seamless experience for the user. So that's mixed reality, right? So moving on, let's move on to how this has been now how virtual reality has been utilized historically in space exploration and space technology. So one of the most early applications of virtual reality has been Virtual Environment Workstation Project. This was early back in 1980s, implemented by NASA, and this was used to train astronauts in uh, virtual spacewalks, uh, repairing your uh, equipment in repairing like space equipment, and for managing like rovers and stuff, rovers. So this was a very early version of virtual reality. It involved more like physical use, and they just had like a screen around them, they put into a room with a rendering of the space station around them, and they were used. It's not exactly virtual reality, it was virtual immersion. We did not have virtual reality headsets back then as proper headsets. They were much more bulkier, they're not as easy to use. So that was the main problem. The second one was how helping was where virtual reality was used was in 1993, where astronauts were used virtual reality and they were using it to prepare for missions like the Hubble telescope repair. So Hubble telescope repair was completely virtualized. It was put into virtual reality, and astronauts and technicians were made to go into these virtual reality simulations and in made to simulate like repairing Hubble telescope in space. This is one of the major use cases, and estimated that it has saved taxpayers, US taxpayers obviously, around $1 to $2 billion for like just space repairs and space training alone, just by accuracy and safety measures and all that stuff. Right now, it has also been utilized in like international space station operations, training, helping astronauts practice assembly, maintenance, and emergencies. So assembly of like space equipment, specific as like conducting experiments in zero gravity, conducting experiments in ISS. All this stuff is simulated on the ground. Trained astronauts are trained on the ground before they can go ahead and do it in space. And this is an extensive process. A lot of steps are involved, and virtual reality is one of the most important steps in training. And as I said, these have helped improve safety, precision, and readiness for these complex space missions. So, right now, one of the latest technological advancements that we have in recent VR advancements would include number one is NASA's Virtual Reality Lab. Virtual Reality Lab has been a very important part of NASA's entire workflow. It uses like entire graphics package called DOUG, which is like DUG, which has a acronym which I'm forgetting right now. And it uses an entire software package to create these simulations. It can create any type of simulation. It is a complete software package. Any person can use it. Even you right now can go to NASA's website and download. In fact, I'll show you how you can download this particular tool from NASA's website. This is what I'm talking about. This is the virtual reality training lab. This is astronaut Christina Koch using this virtual reality software toolkit and like doing her simulations and training in ISS itself in zero gravity. Virtual reality is immensely useful in virtual reality and for training people in virtual reality with ensuring safety of astronauts in virtual reality and in space. As you can see, these are the available flight packages. You can download the software here. There are a lot of plugins and documentations available for people. So anyone interested in creating virtual reality applications for space simulations can utilize this technology and build them right now, today, from their home. This is one of these very important technologies that I wanted to showcase today. The second one is SpaceX's Dragon VR. This is basically used for training astronauts on spacecraft controls. For example, when astronauts go from or like low Earth orbit to space, there are a lot of rockets have a lot of controls on them. This is what SpaceX Dragon VR helps to simulate and helps astronauts safely go from ground to space and so on and so forth. Then there is also ESA's virtual reality for planetary exploration. This is one is particularly used for like controlling your rovers and drones in virtual space in like space. This was actually used in Mars rover. This particular training technology was actually used to train people who were operating the Mars rover. And this has been widely successful, as we all know that the Mars rover has been like operating for 10 years on Mars. The Mars rover, yeah, Curiosity Mars rover. So this is one of the technologies that was used, ESA virtual reality for space planetary exploration. So yeah, this has been used for simulating Mars missions, extravehicular activities, medical procedures, and one of the major things that has now come up in virtual reality is the ability to simulate smells, the ability to simulate temperature to a limited extent, and the massive leap in haptics. Haptics right now has become a very, very big turning point for virtual reality. Virtual reality earlier could only affect one of human senses, two human senses, sorry, the eyesight and the hearing. But now virtual reality can also help stimulate one other major sense, that is the sense of touch. And that's why haptics has become a huge addition, recent addition to these virtual reality enhancements in Virtual Reality Lab and SpaceX Dragon VR, that has become extremely useful for training people for complex tasks and future exploration challenges. Yeah. So let's move on to the next slide. So now I'll talk about slightly more detailed applications in like space. So as I mentioned before, astronauts use virtual reality for training in spacewalks. In fact, I'll show you a small video where astronauts have used a small virtual reality video, 360-degree video, which you can view on your VR set right now. You can view it right now. This is a very small simulation of this particular thing. Yeah, these are a type of simulation. These are just a small video, but astronauts are actually put in these type of simulations. I also have a simulation on with me right now. Unfortunately, the VR headset is not working with the laptop, and there's no internet. I can't quite showcase you or stream this particular experience from my VR headset. But yeah, as you can see, it's a 360-degree simulation. I can see completely. I am seeing from the perspective of the astronaut. This is the hatch. Astronaut is being let into space. As you can see, these are the guardrails that astronauts have to use when going in for spacewalks and going along the edge of the space station or whatever space vehicle they're on. Getting this right the first time is very dangerous. So astronauts go through repeated simulations in virtual reality so as to understand the placement of these rails because the life depends on it. At the same time, they have also connected a rope on their back, which you cannot see right now, but you might be able to see very soon on the other astronaut. Uh, excuse one question. Can you hear the audio in this video?
No, we can't
No.
hear the audio.
Then
Yeah.
I'll give you a commentary of what's happening in this video.
No,
Right now in the background, there is a space
Rahulji,
commander. Yeah.
Sonia, na, what you can do whenever you are sharing your screen, na,
Hmm?
there is a button. If you can on that, na, system audio can
Ah,
be listened to us. Yeah.
yeah.
Please stop.
Can you hear the audio now?
Yeah, 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 we can hear.
Reach up to the handle on your right.
So right now, I'll just rewind back to this
Out
particular
in front
part.
of you and grab those yellow railings. Remember, pull the trigger on the hand controls to grip and pull yourself forward.
So as you can hear, that in this particular simulation, there is a voice in the background that tells the astronaut what to do. and the astronaut is trained this way because in real life as well, the astronaut might not have advanced graphics on their windshield, but they still will have a radio communicator and control, and they can speak to their other astronauts and ground control or the ISS interior ISS control. So just like that, they are simulating this entire experience one to one, where the commander or the ground control will tell them. In this particular instance, you heard that grab onto these yellow railings and move ahead. Similar instructions are given to the astronaut in virtual reality training, and these similar instructions might be given to the astronaut while training while doing the actual job in space. So it trains the astronaut not just physically but also psychologically on how to like be in that environment and how to respond to commands. So it's a very effective conditioning and training of an astronaut.
Take some practice.
Reach up to the handle on your right. Don't worry, it'll all get a lot easier on the arm.
One more aspect that I would like you all to think of and understand. This is a multiplayer. These simulations are usually multi-people simulations. So they also act as effective collaboration tools between people. Here you can see a second astronaut joining the first astronaut, and they are both going to help fix whatever is wrong in this spacewalk and perhaps repair whatever is wrong with this spacewalk, repair whatever is up with this. So it also acts as a potential collaboration tool and also how to act around your astronauts during a spacewalk. It teaches a certain social behaviors to astronauts during these as well. So this acts as effective training.
Here she is.
One
We're
second.
gonna let the crane take the strain. Wouldn't want to drag yourself all the way over on your own, right?
EV2, EV1 will snap you into the foot restraint once you're in place. Head towards the T-bar and grab on.
Okay, you're strapped in and ready to go. The camera's in the toolbox on your tether. It's a point and shoot. Nice and easy. About 45 minutes.
You can see the commander telling them that you have a toolbox, you have everything else, and the person has to go ahead and repair a particular object in the spacewalk now. So as you can see, it's becoming an effective repair simulation as well. Here you can see the giant arm that controls the astronaut that the astronaut is tethered to during the spacewalk. Basically a safety mechanism for the harness so the astronaut does not float away, obviously.
Do you see the Great Barrier Reef? Isn't it beautiful? Sunset in 1 minute.
Just a few more.
In 10 seconds. Turning on
Nice landing, station.
sunset in 10 seconds. Turning on ISS lights.
One more aspect of this is emergency response training, or how to train astronauts to different situations in space. For example, right now you heard the operator say that there is going to be a sunset happening in like 10 minutes. So, what is the appropriate response to the situation? The astronaut might not know immediately. We might not know what to do in this situation, or a new astronaut might not know. So, here they automatically turn on the lights. So, the astronaut in this training already knows that when the sunset happens, automatically there will be these lights that get turned on. So, nothing is a surprise for them because any surprise or unexpected happening for the astronaut in space can be fatal for them.
Motion stop.
Nice landing, station. Okay, EV2. We're ready to disengage you from the arm once you're tethered up. Hook yourself onto the yellow grapple bar in front of you. EV2, look right. Continue pulling yourself along using the yellow handles. that need up and pull out the camera.
Houston, we have debris incoming.
EV1, we copy. Station.
As I mentioned 5 minutes ago about emergency response training, in space there is a big problem of space junk and debris. Debris is common, but space junk or recycled or broken up parts of satellites, the space station, and just human garbage in general is a very big problem because when these space junk start to like orbit the Earth, they move at very high speeds and they can massively damage astronauts, the space station, and other such equipment in space. This is basically fatal. They are like bullets in space which move in clusters. These are very dangerous, and simulating these in virtual reality with haptics and sound and pain and everything is a very good way for emergency response training and how to avoid these, how to predict these using like in virtual reality. And this is how astronauts are trained to like respond to these situations as well.
Repair the airlock. We're in an abort situation. EV2, get back on the arm. Now.
Houston, EV2 is off structure. Repeat, EV2 is off.
Here you can see this
Houston,
is a
EV2 is off
simulation
structure.
where the
Please copy.
astronaut
EV2 is loose.
has lost control of his,
Station has
control of
lost
his arm
visual
and is now floating away into
contact.
space.
Houston,
Yeah, this is one of the small simulations that are generally used. Just a second. So, as we all just saw in front of us, we saw the use of virtual reality extensively. We could see the astronauts simulating grabbing onto these handles, which are basically virtual reality, and dragging them by themselves in virtual reality. It's a complete one-to-one simulation of what would happen in virtual reality. We saw that there were multiple people in that simulation. So it was a simulation for collaboration, communication, effective communication, and training these astronauts in these particular tools, how to train the astronauts in particular situations in virtual reality, how to operate tools within the space station. Everything is being taught to the astronaut before even going to space in virtual reality. At the same time, we are also showing the astronaut how to respond to situations. There can be accidents, how to like respond to situations. As you saw, there was a debris incident, the astronaut lost control. We did not see what happened after that, but there are simulations for that as well. In that case, where one of the astronauts would be just be floating, there'll be a different full team of simulators or an entire team in a simulation which would be given the task to retrieve that astronaut. So it's like a lot of simulations can happen. One person might have a different role in that simulation, someone else might have a different role, but everything is controlled using virtual reality. Everything is controlled in a monitored, safe environment, and everything is controlled so that the astronaut is ready for the real situation when it arrives. So yeah, as you can see, simulates. One thing that I did not show here was virtual reality using medical procedures. I will show that later in a short while. But as you can see, it integrates hybrid reality with physical mock-ups for realistic training. These advancements enhance astronauts' readiness for complex space mission challenges. The second one is where emergency response training. As I said, as we saw, we had an emergency response here in the form of a debris collision, and the astronaut had to respond to that, or astronaut had to simulate that. Similarly, there are many simulations that can be made to help astronauts be ready for a situation. One of the best examples would be fire. Second is a toxic leak. Third is a fluid leak. Surprisingly, fluid leaks are very dangerous in a space station because the fluid can get into a person's eye, into a person's throat, and because it's all weightless, the fluid will not go down your stomach or go down to your stomach. It will be stuck in your throat. You might drown in the fluid. It can be even your own spit, and it's very dangerous. So this is one of the very useful cases where people are simulating. This actually technically falls under a medical procedures category, but I'm including that separately because it happens a lot in space. System failure is another big important thing. Space stations, rockets, flight aircraft, anything that has to do with aeronautics and flight has a lot of redundant systems built into it. And astronauts and flight personnel have to be trained appropriately to utilize redundant systems. For example, if you're flying on a plane can technically land on just one engine, but there are four engines. So a pilot at any given moment must be trained to be able to land with low visibility on the single engine at bad weather. These situations, if we make these, if we train the pilot in these real situations, it is very risky and dangerous. So just like how pilots are trained in virtual reality, astronauts also trained in virtual reality, but for space-related situations. And let me tell you, space has much more challenges compared to just normal flight. So yeah, and communication drills as well. As I said, there was a very similar simple communication drill that you saw in the previous video where there were two astronauts, they're communicating with each other and like going through the simulation. So another aspect of this being used in simulation. So yeah, these are a few images of astronauts being trained in virtual reality simulations. Number one was the image we saw from the virtual reality laboratory, where an astronaut, Christina Koch, is being directly trained in space in virtual reality using controllers and operating on a particular training task. The second way astronauts are trained is using water, underwater. Underwater, these astronauts are controlled by these giant arms which control them and simulate any sort of like external force applied onto them. These astronauts also have VR headsets inside their suits which simulate space, and the water simulates a sort of weightlessness, a real weightlessness, and gives the astronaut a feeling of being in space. This is one of the most high-tech simulations and virtual reality simulations, like fully immersive simulations available to astronauts for training. Nothing beats this. This is one of the most advanced. This is available for NASA and their astronauts. Here you can see a small simulation. This is the perspective of the user from a third person. This is what the third person sees on the user. This is what the user sees. You can see there are controls. There is a small window. Outside we have space, and the person has to operate the spacecraft accordingly. And then we have another small simulation here. These are all images of simulations per se. This is one of the most important ones. This is one already happening in space, and these are minor, smaller scale simulations happening in universities and laboratories across the world. So virtual reality not only allows astronauts at the larger scale to train and perform simulations, it also helps universities and individuals create simulations and facilitate space travel and space exploration. So it's like a great binding tool. It's a democratization of the space simulation and space technology. It is not just limited to NASA, it can also be used by common people like us. So yeah, there's one other video. Here you can see a user is operating a space vehicle on the
Rahul,
moon using virtual reality.
your
Yeah.
screen is not getting shared. Can you
Oh
share
wait,
it? Okay.
wait 1 second. Yeah,
Yeah, now we can see.
I'm sharing my screen. I want to share only my window. Yeah. So did you see the images that I just explained? No,
Yes.
right?
Yes, we can see.
I'll explain them again. Oh, okay, I'll explain the entire all the images again. As you can see, I told you about the first image of virtual reality being used inside space on the International Space Station to train astronauts. This is the first image, right? Do you see this one? Clear. The second image that I'm showing you is one of the most advanced virtual reality simulations available to us at the current time, which is a full body immersive simulation inside water. These astronauts are being controlled by these giant rigs, metal rigs. There is human support. At the same time, the astronauts are put into their actual space suits, and they also have virtual reality headsets inside their spacesuits. So they are completely simulated. Moreover, water here is giving the astronauts a complete sense of weightlessness. This is one of the most important simulations and the most advanced simulations you can possibly have anywhere in the world. It is used to train NASA scientists, astronauts, and engineers for space missions. As you can see, this is a completely underwater chamber, and this is one of the most important ones. Is also accurately like this is accurately used to simulate spacewalks, maintenance, all that stuff. Yeah. Here in the third one, you can see a small simulation created by a single person of space simulations. As I mentioned, virtual reality is a democratization of this space simulation technology. Not only is it available to big corporations and big organizations like NASA, anyone with virtual reality expertise, bit of software understanding, bit of graphics understanding, the game engine can build these space simulations and train themselves and conduct these like simulations for space. And here is another slightly more advanced space simulation with like a three monitor setup and a virtual reality headset. That's basically it for this particular slide. Let's go to the next slide. Here is another video which will show us the how virtual reality is used to simulate the simulate the use of these extra planetary vehicles like rovers and stuff and moon vehicles and stuff. Here you can see this. You can see that the person is using a simulated joystick, actual joystick controller, which will probably also be used on the actual vehicle itself to drive the vehicle and simulate driving that on a surface of a different planet. Here is another training. One of the most important engines that we use is Unreal Engine because of its high graphic fidelity for these simulations. Here you can see a suspended robotic crane, which is used in conjugation with the virtual reality app to simulate microgravity. So not only is water used, but we also use like cranes and hanging to like simulate this gravity and weightlessness. So I believe you were able to understand how important virtual reality is for space missions and space technology. It is such a unique and important technology in the domain of space missions that it can be integrated in so many ways. It's a critical and one of the most important technologies in a space mission, in my opinion, along with artificial intelligence and advanced graphics simulation. So, yeah, as we all saw, virtual reality is used in mission planning and operations. So, it is used for virtual mission rehearsal. We all saw how well it can be used for virtually like rehearsing missions. Second up, it is also used for immersive data visualizations. So we can use virtual reality to like simulate a lot of different scenarios within virtual reality. And then use that to collect some data, real-time data on astronaut behavior, failure rates, psychological behavior, communication patterns, everything else by simulating this in VR, and then create advanced in AI models to predict what might happen in a situation in space. So not only is virtual reality a useful tool for training, it can also be used in conjugation with artificial intelligence to extract real-time data and make better predictive models about astronauts and space missions. So yeah, it can be used to make better decisions in the long run. Remote collaboration, as you just saw, multiple astronauts can be put into a simulation and people can collaborate. Another very interesting aspect and use case of remote collaboration with virtual reality is that astronauts do not have to physically move from one place to the other inside the space station itself. They can connect their using a virtual reality headset. They can connect to a remote drone or a remote robot within the ISS, and those robots can directly conduct maintenance for them, and the astronaut can safely stay inside the ISS, whereas the robot, using virtual reality and telepresence, can go out, repair whatever is wrong with the spacecraft, and return. And this can be done with multiple people in a planned operation. So the value of this telepresence and remote collaboration is immense for the space station. In fact, with more advanced network and communication technologies, I believe in the near future, maybe in 50 years, 40 years, 100 years, we might be able to sit on the ground using a VR headset, control a robot up in space, which is connected to our, like, directly to our actions, and we are directly controlling that robot in space from Earth, from ground, using a virtual reality headset. Right now, unfortunately, that is not possible due to hardware limitations, network connectivity issues, a lot of issues. But in the near future, with the advancement of technology and connection speeds, network connectivity, this will be possible. So yeah, that's another very big, like, important thing. Now, we have spoken a lot about virtual reality. Let's speak about augmented reality. As I said, augmented reality is used to overlay real-time data onto the physical world. As I mentioned, currently astronauts do not have augmented reality enabled visors on their headsets, but that is actually in development in one of NASA's specific augmented reality laboratories, where they're trying to create this augmented reality assisted, but well, assisted like head visors. Let me show a visualization or imagining of that particular headset. I don't think I have an exact image of the perspective of the astronaut from within the uh, suit itself, so that might not be possible to show you. But if the audience can bring their mind back to any sci-fi simulation of a head visor, where information is shown up in a heads-up display on the person's visor itself, that's the kind of technology that NASA or ISRO currently are building, where the astronaut's visor itself acts as a display where information can be overlaid. So this has immense applications in maintenance applications and navigation within the ISS. The spacesuit can overlay information on the person's on the astronaut's visor and tell them where to go, which object to pick up, which maintenance task to take up, which task, or show any potential hazards or hazards happening in the ISS. Suppose you are in your spacesuit sitting on a different block of the space station or a very different corner of the space station. Some mishap happens or some immediate repair or some emergency response situation needs to be taken place. The person's visor can light up showing a small caution sign, and the person can be alerted of this particular thing, and they can be given a straight route or a path of action to the advisor what to do to solve the issue on at hand. This is one of the AR assisted like repair and response technology that can be used with augmented reality for spacecrafts and for space stations. Yeah. For now, we have talked about all these different like benefits, all these different applications. What is the benefit of using virtual reality? As I've already shared quite extensively what the benefits are, let's look over them once again. Number one is 3D modeling and mapping. So virtual reality allows us to 3D model and visualize these surfaces and these 3D objects and immerse ourselves in this situation. Not only can we immerse ourselves into these technical simulations, virtual reality, let me tell you, can also be used to simulate the surface of different planets. Let me show an example. So you can see this is another simulation where astronauts, where you can actually, because we have data on the moon, we can create a virtual reality simulation of the moon itself or a digital twin of the moon and then explore it in virtual reality. You can imagine the applications and the value of such immense like simulation and how they can be applied for training astronauts. This is the moon. We have more information about the moon, but suppose we want to simulate a extraterrestrial planet we have not visited yet. That is also possible, and I'll show you in that in a while as well. You can see it's the complete launch, everything. Let's go directly to the moon. Let's land on the moon.
That would be an honor. Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you do. For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with the in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world.
26, 36 feet per second up. 5 to the pitch over.
I believe that this nation should
Another simulation, but for virtual reality, but for Mars.
Place with a mean temperature that the planet is dead, but the search continues. Mars is 6,000 along with the seasons of the planet. In the past, the planet had water in huge quantities. This water There are also numerous small and big craters and some huge inactive volcanoes. The biggest volcano on Mars is Mount Olympus and is 25 kilometers high. Its base covers 600 kilometers. This volcano is the biggest in the solar system. Across 1/5 the circumference of Mars.
So as you all saw, let me show you one final one. The simulation, bit of the black hole. So using virtual reality, not only can we simulate stuff like Mars, Moon, but we can also simulate theoretical concepts which humanity might never be able to experience themselves. Like what simulation around a black hole might feel like from a human perspective. This is one of these. So yeah. As you can see, not only can virtual reality help us visualize these advanced technical and space concepts, but also help us understand them better. Complex data visualization, as you can see, we can create giant simulations, put data into them, and then visualize them effectively. Another use case, and interactive learning, as we all saw. The speaker in the Mars video was telling us different facts about Mars, and as we were going through Mars in virtual reality itself, right? So it also helps in interactive learning. We could quickly, by just seeing Olympus Mons in front of us, we could immediately see the width, its height, and understand the grand scale of how big the volcano is on Mars. Just by looking at the crater, the giant scar across the Earth, we could tell that was a giant scar. By looking at the craters, that in the video itself, we could tell Mars once had water. So just by putting a user in a more immersive learning environment, we can understand and learn about space better. That's another application. This is a technological benefit of using virtual reality. Obviously, there is improved safety and efficiency. There's risk mitigation. As I said, everything in virtual reality is done in a safe environment, in a simulated environment, without any risk to the user. That is pretty very well understood. I don't have to elaborate on that point further. And efficient resource management. Now, efficient resource management needs to be explained a little bit. As we go through more and more simulations on a particular thing, we gather more data. And as we gather more data, we make more optimized decisions. Not just optimized decisions, but it also helps us optimize the variables in a particular simulation. For example, by simulating multiple scenarios, we can optimize the fuel usage, the food amount of food an astronaut might need during in a space mission, the power usage, consumables, etc., etc. So there are certain resource management simulations by NASA, and ESA has developed some smart allocation systems based on these virtual reality simulations that have improved the efficiency of these space missions immensely. And as I said, virtual team meetings, we talked about that prior, and cross-disciplinary collaboration. We talked about that as well. So using AR, VR, multiple different collaboration teams, engineering, science can all come into the same environment. They can talk to each other. They can put up 3D objects, which they both can like work on and share, and potentially improve the understanding of this mission, and so on and so forth. This encompasses both virtual team meetings and cross-disciplinary collaboration. And we also saw how it can be used directly in space missions as well. Number 4. Now, we talked about the immense technological benefits, the immense scope of this technology use in space missions. Now let's talk about the very realistic challenges and limitations that exist currently in application of this technology. Number 1 is hardware. Now, virtual reality headsets are a simulation of reality or a parallel simulation of reality. They require very specialized devices which have very high specs. For example, my Meta Quest 2 alone, which is a last gen headset. We have Quest 3, we have Quest 3 Pro, a lot more advanced headsets on the market right now. Even this requires a 72 Hz frame rate for both its displays, and 90 Hz, minimum 72 Hz, and 90 Hz as recommended for a smooth experience. So, for even higher, more realistic simulations, you need a higher frame rate. At the same time, you also need better real-time sensors, and that involves a huge amount of graphical processing power condensed into a small device. That is the most biggest hardware limitation we have right now. Along with that, battery, memory constraints, equipment is also a very big challenge for use of virtual reality in this particular space simulations. But let me tell you, virtual reality by far is the most cheapest version of space simulation compared to any type of space simulation we have had before. Virtual reality itself is constrained by its own technology, but it, as a part of space technology and mission technology, space mission and training technology, is a huge cost saver and is highly efficient. So yeah. Second is connectivity issues. If we are using multiplayer simulations or multi-person simulations, we need a 5G network at the minimum for efficient like movement across, for efficient like simulation, multi-user simulation. Because any small amount of lag can completely break the immersion and destroy the purpose of the simulation. That's why one of the biggest constraints and one of the biggest enablers of virtual reality in the future will be high-speed internet, especially 5G and 6G. Even 4G to an extent is very useful and does solve virtual reality simulations for highly optimized virtual reality simulations. But if we want raw processing power, raw graphics, we need 5G and 6G, and it is possible. And we are building it. NASA has built it. Certain giant organizations have been successfully able to implement this, and the benefits have been immense. But it is out of the reach of the common man because high-speed connection technologies are not as readily available. The second is human factors. Number one is training requirements. Now, although virtual reality is one of the best training mechanisms which translates into actual mission readiness, it is not a one-to-one simulation. So anything that the astronaut might train incorrectly in the simulation might carry over to the real world, which can become an immense problem. So human factors and human negligence and human misunderstandings during virtual reality training can lead to catastrophic, disastrous consequences later down the road as well. So yeah, and obviously users need to be prepared to train in virtual reality first, then in real life. So it adds an extra step, which is a very required, necessary step, but it adds another step nonetheless. Second is user interface challenges. Virtual reality is a very complicated simulation. So the purpose of the simulation is to make training or to train a user. So its user interface will be very different from other things, from a very traditional 2D software. So it requires dedicated and specialized knowledge of specialized designers to build these UX user interfaces. So that's another major challenge. How do we design these systems, these user interfaces effectively so the training purpose or the simulation purpose or the visualization purpose or whatever purpose we are building the simulation for is carried over to the user and is effectively understood and can be utilized by the user. Yeah. Cost and resource allocation. Simulations, as I said, require money as software. As any software, it requires development costs. Developers requires developers and development costs. So, like virtual reality simulations are quite intensive and hard to build, and they require very specialized knowledge. So, finding such talented developers who can build these simulations effectively is also difficult. So, this is one of the major constraints right now in the industry as well. Finding talented enough engineers who can build these extensive virtual reality simulations. The second is maintenance. Virtual reality equipment are delicate equipment. They are hard to maintain. They require constant cleaning, not as much as old technology, but they do require maintenance nonetheless. So to keep them at 100% operation, you have to maintain them accordingly. Pretty basic. So yeah, future prospects. Advancements involve AI integration. So we heard an operator right in these videos before. That operator could entirely be AI, guiding a user on how to repair a particular object, how to perform a spacewalk. The AI could help the user, assist the user through emergency response situations, and so on and so forth. Combining virtual reality simulation with artificial intelligence, combining augmented reality with real-time augmented reality during a mission with artificial intelligence will provide immense benefits to space missions in the terms of safety and effectiveness. Second is enhanced realism. Right now, as I said, VR headsets require a lot of immense frame rates and 90 hertz frame rates on both displays. Consequently, the one thing that most simulations have to compromise on is the graphics. With advanced headsets, with better headsets, with better connectivity, better internet, we can build simulations that are more realistic and involve haptics, involve sensory, olfactory simulative mechanisms, which simulate the virtual reality experience to a much more higher degree and give a better understanding for the mission and a better immersion to the user. Enhanced realism. Yes. So advanced graphics and sensory feedback. Sensory feedback here mainly involves haptics, olfactory, and better surround sound and audio perhaps. So how can we expand these applications? We can do Mars and beyond. As I said, these applications, people are using these applications to like create software that will facilitate simulations and software will facilitate human exploration and potential colonization of Mars. People are simulating how to colonize Mars in virtual reality right now. And these simulations that are happening right now will bear fruit in 50 years in the future. Not just Mars, we are simulating how to colonize other celestial bodies as well. For example, the one of Jupiter's moons, Io and Europa as well. So, and another way of using these virtual reality simulations is to simulate long duration missions. So, and by doing this, we'll be able to address the issues of human health, sustainability, and deep space travel through advanced life support and habitat systems. Before we build those, we could simulate what sort of effects they would have on humans themselves, and simulate and create these technologies accordingly. The last is space tourism and commercial space flight. One of the examples is person can be given a VR headset, taken onto a spacecraft, taken to space, put in the sense of weightlessness, and the virtual reality headset would make them feel like they're not in the interior of the spacecraft but in space itself. This is one of the very useful and unique applications of space virtual reality in commercial and tourism related spaceflight. So this is one of the expanding applications of virtual reality in spaceflight. So in conclusion, as we saw, virtual reality and augmented reality is not only a very important aspect and a very useful technology in terms of space missions, but we also find its unique applications not just in tourism but also in commercial applications, in training, in learning, in education, and for emergency responses, medical procedures, and so on and so forth. Yeah. Thank you, everyone. So that's the end of my presentation. I'm Rahul Ghosh. I work at Infinite Reality. I build WebXR applications and WebXR engines. So basically, we facilitate the use of virtual reality through websites and not just VR headsets, but you can access virtual reality through websites as well. That's what we do. That's what I do. I build the software that enables that. And that was me. And that was a brief explanation of how virtual reality can be used in space missions. Any questions? We can, with the last 20 minutes of this presentation can be dedicated to questions. For any further queries, anyone can reach out to me at my personal email that is given in the slide below. So yeah, any questions, anyone?
Yes, participants, the forum is open for question answering. You can unmute yourself and ask the question. Yes.
Sir, I have one question.
Please go ahead.
Is my voice audible?
Yes,
Yeah,
yes.
yeah.
I want to know whether this AR VR technology is what is the efficiency in zero gravity?
What do you mean by efficiency? The thing is that they are just they're just like any other electronic component, right? They're just like your TV display. Just like how TV displays work perfectly on the ground and in space, right? Virtual reality also works effectively the same way as you see on the ground in space. It's just a display attached to your head. There is no such loss in efficiency. In fact, it is more immersive because not only are you feeling weightlessness, but you're also being simulated which you're also simulating whatever mission function you have in that in space as well. So yeah,
Okay, thank you, sir.
there is no such loss in efficiency.
Okay, thanks.
Yes, participants, any other questions that you have? No? Last call. Okay, so I think there are no more questions, Rahul. Yeah, so thank you very much for delivering a wonderful session on this AR, VR, and XR, which is very useful in space domain. It has a tremendous application. Right, so thank you so much for delivering such a wonderful session. Yeah. Participants, I have posted the links, the attendance and feedback links in the chat box. Just fill them and then you can take a leave. Thank you, Rahul. You can take a leave from this.
Once again, I apologize for my throat infection and my poor voice.
So,
Thank you, everyone.
Even if you have such a throat infection, so we decided not to conduct the session again. You agreed upon delivering the session and you conducted very well. So thanks to you for the thing.
All right, I'll take my leave then. Thank you, everyone. It was a wonderful session. Thank you.
Thank you, sir.
Thank you, ma'am. Posting the links in the WhatsApp group. Fill them. And then you can take a leave from this meeting. Thank you. I have already posted. Please check it and fill them. Good night. All of you, good night.